Hello guys, good morning. This is Mr. Technician. I will show you today guys how this Linde H2TF control works. Okay, stay tuned. So I have this pump here guys, this Linde HPV, but it's a 105 displacement, and with this control type. So never seen this before. Okay. Normally the Linde control that I experience is this type here, like this H1P with PCO, pressure cut off, like that, and some are solenoids control, but this one here is a bit different. So this is H2TF. So that's the control. So I print out a big one and try to figure out how this control works. And if you look the circuit guys, this one here, show you the circuit here, this one, very interesting. So this is the pilot valve, which is number 5. That's where the spool and sleeve. This pilot valve command the displacement stroke piston. So this displacement stroke piston number 1, this assembly here is, if I show you that one, that is, bear with me guys, okay. This is the big one that here, number 6. All right, this one here, these two are the displacement stroke piston. Okay, so let's go back to the circuit. Okay, all right, so this one here is more on speed, engine speed controller. So you can control because see, if you follow that line, that is from your Y and Z. Okay, Y and Z. So you can, that one there, you can remotely control that, depend on through N, port N. Okay, and also this one here, I'm confused because I can't find this valve. Okay, in this cross sectional. All right, so I can't find that one there. So this is the pilot valve. This is the pilot valve here. This one here is the slave piston. So this is where the Y and Z acting. So one is Y and the other end is Z. So this is the spool or the piston or the spool that move and then affect the pilot valve because of the link. See this link here, that's the feedback lever. Okay, feedback lever. This here, number 36, that's the here, this one, 36. All right, so when the X is commanded, so this will shift and then it control the other, the if Y, the Z will be tank, obviously, because this is from your command, pilot command. So either pressure reducing or solenoid control. Okay, now this one here, 33, these are the torque control. Okay, so it's a ratio, so pressure from your system against pilot pressure. Okay, so it's a torque balance. Okay, so that the engine will not stall. Obviously that is set by the spring and shims. Okay, now this feedback here, okay, this part here is the feedback control. So how the feedback control works, I show you. So here guys, this is the piston, the slave piston, or the actuating piston, spool. This one here, this where the Y act there, so Y and Z. Okay, that's your pilot command. This one I just put N-hex Allen key there. This is the lever, the feedback lever. This spool inside is this is the pilot valve assembly. This is where you adjust your neutral. So make sure your A and B are the same at neutral. So if not, then you adjust the thread. Okay. As you notice, when I will remove this one here. Okay. So this one here is your. Okay. So this one will be like that. Will be like that. Okay. So this port here is your boost pressure. This one, this is your go to the displacement stroke piston. So D1 and D2. And then this one, that is drain. This one, this port. So this is drain. This is, let's say, A and B and then P. And then this is drain as well here. As you notice, the spool has a notches, so meaning it's a variable. See that notches there, and the other side as well. Okay, so meaning at neutral, your A and B drain to tank, but throttling. Okay, so the way it works, guys. Okay, I just put this one without the spring. Without the spring so that we can, so make sure it's in neutral. Okay, up that one there. So we make sure that it's in neutral, A and B. Okay, now the ports, now it's in neutral. The way the feedback works, so let's say the Y, so I put that one there for your make it center. So let's say there's a Y command. So let's say that one there, command. You notice that the lever move on the right side. So meaning the spool move on the right side. And then once that move, it's applied to either A or B. And then the swash plate of the pump will move as well. Depend how much the command, because it's a proportional, guys. Once the swash plate move, and because this one here is connected to swash plate, this will back to neutral. So that one there will go back to that position. So if we simplify the circuit, let's say, so the control Y, P to B, and Z, P to A. All right, let's see. This one here, the control Y. All right, there is a pilot pressure. There is a command, meaning there's a command from the operator to tilt the pump. So obviously this one, because it's a link, it opposite way. So this is that this side will go to the right, but this one go to the left. All right. So what happened is P to B. So by the way, in neutral, you can see it's open to tank drain. So P to B, so that one will move. All right. So when B is open, so obviously the swash plate will tilt. Depend how much the command the operator need. If it is quarter, half stroke, 3/4, or full stroke. So once that swash plate move according to the command, because it's a proportional, and then because this one linked to the lever, this one will move back to neutral. So that means if half stroke, the command is half stroke, the swash plate only displays half of the displacement of the total displacement. So otherwise, the swash plate is keep going without the feedback control. So once that go to neutral, so the swash plate maintain on that position. When there is a leakages, it will compensate, will like that. So this spool, guys, is always moving. Okay, this is exaggerated, but that's how the spool move inside the sleeve to balance the spring. Okay, now remember that's in back. So when you remove the signal from Y, obviously the spring pushes the piston or this spool here pushes that way. So what happened is if it is pushes to the left, this one go to the right. So what happened if because of the lever, this will go to the right. So P to A. So what happened now? Your swash plate will, this stroke will go back to the neutral position. Once the swash plate move, because there's a link connected to the pilot valve, so once that swash plate move to the other way to neutral, this will go back to the neutral position, and then of course everything is spring is balanced. So that's how the feedback works. And yeah, so I just found out that this control here is proportional pilot control on your flow. It is a positive flow control. Then this one here is your torque control or torque balance. Okay, and then what I'm going to do, because I'm going to use this as my test rig, I will plug the torque control and then I will just depend on the relief valve so that it won't change my speed driving my hydraulic motor. So yep,